I'm Dr. Nicholas Gray-Evans. I'm a postdoctoral associate in the Department of Earth and Atmospheric Sciences at Cornell University. I work on both late Paleozoic climate and also I work on the meteorology and past climate of the planet Mars. I like to think that Mars is sort of a way of looking outside of the box of the Earth, a way of getting rid of all of our assumptions about the way things work, looking for familiar patterns, of course, but also allowing it to challenge us, allowing us to really think about what we see on the Earth in a completely new way.
We've had a few presidents now talking about going to Mars, but it never gets any traction and it never goes anywhere. And it's something that, it's something that the human race is going to do eventually. I read one of Zubrin's books, and I did whenever I was working on the script, of course I always wanted to know what the hell I was talking about.
What should the goal be? As Dr. Huntress has said, it should be humans to Mars.
Mars is the next step.
Mars is where the science is. Mars is where the challenge is.
Mars is the future.
Mars is where the future is.
As far as how it can be done and the most workable ways to do it, I was very fascinated by Zubrin's methodologies and sending two separate rockets, and you get your own fuel on the surface, and hopefully there's water there.
Our best thinking is that in the high latitudes of Mars, the equivalent to the Arctic and Antarctic Circle, there are deposits of ice, ground ice. In some cases, it would look like an exposed frost. In some places, it would just be this sort of icy, slushy kind of, it would be pretty hard slush mixed into soil that you probably have to heat up in order to get off the water. Or if you dug for 10, 20, 30, maybe more meters, you could hit substantial deposits of actual ice, things that people would recognize as, nearly out of your freezer.
It's funny because when I was reading the book, there was one part of it that he talked about, and I was like, I don't know if he's got this covered, and it actually came out in the script, in the storyline, and I thought this before, which is the radiation side of it. I was like, he's got some vague ideas about how to deal with the radiation, but it kind of seemed like between the lines he's saying like, yeah, well...
There are ways to mitigate the effects of radiation on the surface.
What if solar flares in transit? You're always talking, go, go, go. Look what happens.
I didn't send him there. The people who did this, they'll all eventually get really bad cancer and die, so that'll be a drag, but we should do it anyway. And I'm like, that part we gotta work out, but...
There are a variety of possible habitats, but the strongest one, and perhaps the easiest one to find on Mars, there are pictures that look potentially like they exist, are lava tubes. So basically are caves.
I can't believe they'd be able to dig out underground habitat. Do you have any idea the weight requirements for a drill that size?
Natural caverns, the drilling could be minimal.
You go into these caves and you get a shield from radiation.
And all these ways of actually making it work are really fascinating. I really love to read about it, and he really made it seem doable. And I do think that there's something too that is a difference between Walser and Zubrin, or maybe it's just more exaggerated in Walser, is that in spite of the fact that he's like, we got to look at hard, cold facts and be realistic about everything, he does have a way, and it comes out with Alexei, of some of the hard, cold facts that are not real convenient. He's willing to just sort of brush those aside.
If we can prove that this water came from Mars,
then maintaining life on the surface would be possible.
more than possible, where there's water,
there is potential for life.
He lets his biases about the way he wants to definitely affect his scientific method a little bit. It would be huge news if all of a sudden there was a manned mission to Mars. It would be like it was back in 1969. People would be riveted by it. And it's something that, you know, like I said, something humanity is going to do, and it's something we need to do.
It's possible that we might not explore Mars until we have a completely different architecture for doing these kinds of missions. But I think we need to do it. Mars is a new world. I feel that it's sort of a museum. It's something that hasn't been messed around with plate tectonics for billions of years, and it's sort of stopped at a point. It's like a window into what the early years of our own planet might have been like. We all, in our jobs, want to have noble aims. And, you know, I think that what you're trying to do is the very kind of noble aim that we go into the business doing. We want people to be excited about these things. As scientists reading science fiction, we don't care about accuracy. We don't read science fiction to see the world as it is. We want to see the world as it could be, as hypothesis, as potential, as a way of stimulating our imaginations. I don't know what your future looks like, but these 6 episodes, at least, I'd like to show them to people in my field and say, you know, these guys working with a low budget are really doing what good science fiction television should be doing.
Progress is being made.